Okay, we're going to look at a few other momentum type scenarios. Again, that could be solved using basic dynamics and kinematics, but we'll try with some momentum here. Let's start by drawing some ground. I'm going to draw something like this. Maybe it's like a brick wall of some kind. There we go. Alright, so there's a wall. I'm going to draw a ball. It's not very round, but that's okay. Alright, I'm going to draw the ball like that. And I'm going to draw somebody actually kicking the ball. So here's somebody, and they kick the ball. Alright, and the ball goes forwards, hits the wall, and then of course bounces back. Alright, so let's say we have a 0.80 kilogram ball, and it goes towards the wall at, let's go with 10 meters per second, and then bounces back at 4 meters per second. And I want to know the impulse of the ball when it hits the wall. Okay, well, let's just start by finding momentum. So let's just start with that. So on the way there, if I do momentum on the way there, P equals mv, I've got the 0.8 and I've got the 10. So let's multiply those together, and you would have 8.0 for momentum on the way there. On the way back, I can do the same type of thing. On the way back, I can do momentum is equal to mv, and I'll call it v2. This would be v1. So on the way back, with the second part, I've got the 0.8, I've got the 4 multiplied together, and I've got 3.2 kilogram meters per second on the way back. Okay, so now I'm looking for the impulse for the ball when it hit the wall. Now, if I do that, of course, impulse is change in momentum. And you might want to just do 8.0, take away 3.2, which is going to give you 4.8 for an impulse. But that would actually be wrong. Now, the reason why that's wrong is because of the change in direction. Okay, if we actually sort of slow this down a little bit, let's just have the ball hit the wall. Now, when the ball went in, it had 8 for momentum just to go to the wall. In order for it to stop, in order for the wall just to stop the ball, you need 8 kilogram meters per second of momentum just to stop it. And we'll say technically -8. So you need -8 just to stop the ball. But the wall didn't just stop the ball, it also threw it back with 3.2. So not only did the wall stop it, it also moved it back with another -3.2 kilogram meters per second for momentum. And we need to take those two and put them together, and the total impulse or change of momentum would be -11.2 kilogram meters per second, or 11.2 to the left. Okay, which is a lot more than what it even started with. But remember, this is the change in momentum, not the actual momentum. All right, so the ball came in with 8 for momentum. The wall stopped it, so it took away 8, and then threw it back with another 3.2 for a total of 11.2, which allows it to have its 3.2 on the way back. Okay, so a little bit more challenging with the change in direction. You gotta be a little bit careful with that, because momentum is a vector quantity, but just take it one piece at a time, find out how much momentum or impulse there was to stop it, how much it was to actually go back or change direction, and then sort of piece things together. If the impulse had only been 4.8, if you think about it, if the ball came in with 8 for momentum, all right, so if it actually came in with 8 for momentum, and the impulse had only been 4.8, then the ball hasn't even stopped yet, and the ball would actually go right through the wall and just keep on going, which would be kind of cool, but that's just not going to happen. All right, let's try something else. All right, here we have this. I'm going to draw a skateboard over here. All right, so skateboard, I have a little kid. All right, so we have this little kid. We have a, let's say we have a 28 kilogram kid, and he's running at, well, let's go with 3.5 meters per second to a skateboard. we'll make it a pretty heavy skateboard, so this will make it a little bit, will actually work a little bit better. Let's say we have a 4 kilogram skateboard, maybe it's made of like steel or cast iron or something like that, and it's just sitting here at rest. Okay, and I'm just going to take those measurements, I'm going to move them down here. There we go. All right, so what he's going to do is he's going to run along. He is going to run, jump on the skateboard, and then him and the skateboard are going to go off together. Okay, so let's just start by finding his momentum. So if I start by finding his momentum, just do P equals mv for the kid. We've got the 28 kilograms, so we'll times that by 3.5, and he's got 98 kilogram meters per second for momentum. Now that's the only momentum we're starting with. The skateboard over here has nothing. It has no momentum whatsoever because it's not moving. So if this is the only momentum that we're actually starting with, this is what we have to end with. So we also have to end with 98 kilogram meters per second. But afterwards, it's not just him, because he's run along, run. He's jumped on the skateboard, and now the two are going off together, and hopefully he's not running anymore. So this momentum that he had is now transferred to both of them as they move off together. So this 98 is the momentum of the two put together. So to find out how fast they're going afterwards, that is just momentum divided by mass. Well, the momentum is just the 98. The total momentum can't change. And for mass, now that they are together, they become one mass. They're moving off together. So this would be 32 kilograms instead of just the 28 or the 4. So we'll take the 98 and we can divide that by the combined mass of 32. And they are going off at about 3.06 meters per second. So a little bit slower than they were before, not a whole lot slower because the skateboard isn't very heavy compared to him, but they will slow down a little tiny bit. All right, well, let's try a third question a little bit different. All right, let's draw some grass here, and that. All right, here we got a marshmallow. Let's draw. Let's see. Guy. Something like that. Shade him in a little bit. Alright, so here's a porcupine. Alright, so we've got a marshmallow and a porcupine, and they're going to come together. Let's see if we can give him a little smile here, some eyes. Kind of a creepy looking porcupine, but that's okay. Alright, so we've got a marshmallow and we've got a porcupine. They are going to collide and stick together. Obviously, a porcupine hitting a marshmallow is going to stick to the porcupine pretty good. And let's say we've got, let's say this is a 15 kilogram porcupine. Let's say this is, marshmallows are kind of light and fluffy. So let's say this is just a 6 kilogram marshmallow. And let's say our porcupine is running towards the left and our marshmallow is running towards the right. And let's say the porcupine is going at, let's go with 4 meters per second. All right. So they're going to collide and stick together, and afterwards, and after the collision, they are going 1.5 meters per second towards the right. So the marshmallow is actually going to win, which tells me that the marshmallow actually has to have more momentum than the porcupine did to start with in order for it to be moving to the right after the collision. So let's just start by finding some momentum, some before and after type stuff, and piece things together. All right, so I'm going to look at some before stuff and just piece a couple things together. I don't know the momentum of the marshmallow. I don't know what that is, but I do know the momentum of the porcupine is going to be the mass of the porcupine times the speed of the porcupine. I have both of those. And I've got the 15 and I've got the 4, which gives me 60 kilogram meters per second towards the left. I can also find my total because I have both masses. I know they stick together. And afterwards, that's going to be my total momentum afterwards because they become one object. Afterwards, the momentum is going to be mv. Mass will be the total mass, and the v, that is the 1.5. So if I add the masses together, so I got 21 kilograms altogether, and I times that by 1.5, I've got 31.5 kilogram meters per second towards the right. Okay, so let's piece a couple things together here. My porcupine came in with 60. I don't know what the marshmallow came with, but I know afterwards, after they stick together, they've got 31.5 going towards the right. So that tells me that definitely, once again, the marshmallow won, and I'm going to try and use that information to find out how fast my marshmallow was going. Okay, let's see if I can piece this together for my marshmallow. Well, the porcupine came in with 60, and the marshmallow actually won afterwards. So first things first, I know that my marshmallow for sure, had 60 in order to actually stop the porcupine. Okay, it had to cancel off that 60. So if the marshmallow had come in with 60 and the porcupine had come in with 60, they would have come together and just stopped. But not only did the marshmallow stop the porcupine, it actually then won and kept on going. Sort of like the ball question we did a little while ago. So the marshmallow had 60 just to stop, but not only did it stop, it also won with 31.5. Okay, so the marshmallow at 60 stopped, but it also had another 31.5 in order to win and keep on going towards the right. So I'm going to put those two together, and my marshmallow must have had 91.5 kilogram meters per second of momentum. So my marshmallow came in with 91.5 kilogram meters per second of momentum. Marshmallow came in with 91.5. I found out before that my porcupine came in with 60. Porcupine came in with 60 this way. Marshmallow came in with 91.5 that way. Since they're going in opposite directions, you would subtract the two, and the total momentum for those would be 31.5 to the right, which is exactly what we had down there. So now that I have my marshmallow's initial momentum, I can find out how fast it was going. So I'll take the 91.5 and divide it by the mass of 6 kilograms. So I've got 91.5 divided by 6 kilograms, and the marshmallow was going around 15.3 meters per second. Okay, so a question like this is all just find momentums. You know, you could find the porcupine momentum, you could find the momentum afterwards, and since they were one thing, that was also the total momentum, which can't change, and then sort of piece things together to find out what the marshmallow must have had in order to add up to the 31.5. And I like to piece together and try and use a little bit of logic. Just, you know, suppose they had just tied, maybe they'd be equal. Well, then the marshmallow would have had 60 just to be equal. Well, not only was the marshmallow able to stop the porcupine at 1, it must have won with 31.5 because that's what they have on the way back. And then I just sort of pieced them together to figure out the marshmallow had 91.5. And then once you have that, you can also just take it back, put it back in the original situation to see if it makes sense. Okay, if the marshmallow came in with 91 to the right and the porcupine came in with 60 to the left, and you put those two together, you'd have like 31 to the right. So the total momentum to start with would have been 31 to the right. Total momentum can't change. If you have 31 to the right at the beginning, you should have 31 to the right at the end, and we did. So it's a really good sign that everything was pieced together correctly.